Hello, everyone. Today we're going to go over the homework for section 4.3. So number one, we're given this data set and we're asked to find the mean and the median. So we have 10 data points. 10 divided by 2 is 5. So the median will have 5 below and 5 above. That's going to be between 3 and 4. The average of 3 and 4 is 3.5. So the median is 3.5. The mean, X bar, we add them all up and divide by how many we have. So add them all up and divide by 10. 1 plus 1 plus 1 plus 2 plus 3 plus 4 plus 4 plus 5 plus 6 plus 7 is 34. 34 divided by 10 is 3.4. So X bar, the mean, equals 3.4. Number two, we're doing median and mean again. This time our data is 5, 8, 9, 9, 10, 10, 10, 15, 18, 21. There's 10 data points. Half of 10 is 5. That means there's 5 below and 5 above the median. We split that in half. It's between 10 and 10. So the median is 10. The mean, X bar, add them all up and divide by how many we have. So we're adding them all up and dividing by 10. 5 plus 8 plus 9 plus 9 plus 10 plus 10 plus 10 plus 15 plus 18 plus 21 is 115. 115 divided by 10 gives us an X bar, a mean of 11.5. Number three, again, mean and median. We've got 10 data points, 5 below, 5 above. That means we're between 3 and 5. Between 3 and 5, we have 4. So the median is 4. The mean, X bar, add them all up and divide by how many we have. So we're adding them all up and we're dividing by 10. 1 plus 1 plus 1 plus 2 plus 3 plus 5 plus 6 plus 9 plus 14 plus 19 is 61. 61 divided by 10 is 6.1. In number 4, we are asked to find the mean and the standard deviation for the given data set. So first, count how many we have. We have 5. So n is 5. And eventually we're going to need n minus 1 for the standard deviation. N minus 1 is 4. It does not specifically say that this is a population, so we assume it is a sample. And in the samples, we use n minus 1 for the standard deviation. So the mean, X bar, add them up and divide by how many we have. We add up 0 plus 10 plus 12 plus 15 plus 18, we get 55. Divide by the 5 we have. X bar, our mean is 11. So remember, to find standard deviation, our first column is a column with rows for every data point. So a row for 0, a row for 10, a row for 12, a row for 15, and a row for 18. I had said in lecture, if you want to put a column in that is just the X bar, that is just the mean for every row, feel free to do that, because when we have our column for X minus X bar, it's easy to see 0 minus 11 is negative 11. 10 minus 11 is negative 1. 12 minus 11 is positive 1. 15 minus 11 is 4. 18 minus 11 is 7. Then we need a column for the squares. So we square the X minus X bar column. Negative 11 squared is 121. -1 squared is 1. 1 squared is 1. 4 squared is 16. 7 squared is 49. Then we need the sum of the squares. If we add up 121 plus 1 plus 1 plus 16 plus 49, we get 188. The standard deviation is going to be the square root then of 188 divided by 4, divided by n minus 1. 188 divided by 4 is 47. The square root of 47 is 6.86. So our mean was 11, our standard deviation, 6.86. In number 5, once again, we're finding the mean and the standard deviation. The mean, the average, the X bar, add them up and divide by how many we have. And we have 1, 2, 3, 4, 5 data points. Add up 3 plus 5 plus 7 plus 8 plus 12. We get 35. 35 divided by 5 is 7. So the mean, the X bar, is 7. For standard deviation, we need n minus 1, which is 4. Set up our column with our X values. 3, 5, 7, 8, and 12, a row for each. You can put in your column with the X bar. That was 7 we found. And now we can easily go 3 minus 7 is -4. 5 minus 7 is -2. 7 minus 7 is 0. 8 minus 7 is 1. 12 minus 7 is 5. Finally, a column for squaring each of those. -4 squared is 16. -2 squared is 4. 0 squared is 0. 1 squared is 1. 5 squared is 25. Let's find the sum of the squares. Add up this column. 16 plus 4 plus 0 plus 1 plus 25 gives us 46 for the sum of the squares. The standard deviation then is the sum of the squares divided by n minus 1, and we take the square root of that. So we have the square root of 46 over 4, which is the square root of 11.5, which is 3.39. So we found the mean X bar of 7 and the standard deviation of 3.39. Once again, in number 6, we're looking for the mean and the standard deviation. Again, we have an n of 5. We have 5 data points. Our n minus 1 then would be 4. So for the mean for X bar, add them all up, divide by 5. 4 plus 4 plus 6 plus 8 plus 11 is 33. 33 divided by 5 is 6.6. For standard deviation, make a column for our X's. Put in each data point. 4, 4, 6, 8, 11. You can make a column for X bar. That was 6.6. Fill that in the whole way down. And now we can easily subtract 4 minus 6.6 is -2.6. 4 minus 6.6 is -2.6. 6 minus 6.6 is -0.6. 8 minus 6.6 is 1.4. 11 minus 6.6 is 4.4. Square each of those. -2.6 squared is 6.76. We have that twice. -0.6 squared is 0.36. 1.4 squared is 1.96. 4.4 squared is 19.36. Then we need the sum of the squares. 6.76 plus 6.76 plus 0.36 plus 1.96 plus 19.36 gives us 35.2. So 35.2 is the sum of squares. The standard deviation is the sum of squares over n minus 1, and then take the square root. So we have the square root of 35.2 divided by 4, which is the square root of 8.8, which is 2.97. So the mean was 6.6, the standard deviation, 2.97. Number 7, the mean of the data set is given. Find the missing value. So we're told that X bar, the mean is 18. We're given 6 out of 7 data points, 12, 15, 17, 19, 22, and 28. And then we have a missing value. The average, the mean, would be all 7 added together divided by 7. If we add up the 6 that we know, 12 plus 15 plus 17 plus 19 plus 22 plus 28 gives us 113. So 113 plus the unknown, we'll call it X, divided by 7 must equal 18. So let's do some algebra. We get rid of dividing by 7 by multiplying both sides by 7. That means 113 plus X is 126. Subtracting 113 from both sides means that X has to be 13. So the missing value is 13. We're doing this again. Again, we have 1, 2, 3, 4, 5, 6 out of 7 pieces of data. We're given that the mean of the data is 52. So that means that if we add up all 7 and divide by 7, we get 52. If we add up the 6 that we know, 42 plus 45 plus 51 plus 58 plus 63 plus 75 is 334. That means that 334 plus the missing value, all divided by 7, has to equal 52. So we do some algebra. Get rid of dividing by 7 by multiplying by 7 on both sides. That means that 334 plus X is 364. And subtracting 334 from both sides, we get that X must be 30. So the missing value is 30. In number 9, we're going to consider the following 2 small distributions. A is the distribution 5, 7, 9, 11, 13. B is the distribution 5, 7, 9, 11, 21. Let's find the mean and median of each of these distributions. They both have 5 data points. The data point right in the middle is 9 for both. So the median of A and the median of B are both 9. To find the mean of A, we add them all up and divide by 5. 5 plus 7 plus 9 plus 11 plus 13 is 45. 45 divided by 5 gives us 9. The mean of A is 9. The mean of B, add them all up and divide by 5. 5 plus 7 plus 9 plus 11 plus 21 is 53. 53 divided by 5 is 10.6. What do you notice about these results? Well, the medians are the same, but the means are different. Kind of piggybacking off of number 9, we have number 10, which says make up 3 data sets with 5 numbers each that have the same mean but different medians. So in order to have different means, in order to have different medians, the third value of each of the 5 has to be different because the third value is the median. So one possibility is we create one that's 5, 10, 15, 20, 25, and we make sure that the middle number is different for B and different for C. So I have 13 as the middle number for B. I have 14 as the middle number for C. 15, 13, and 14 would be the medians, so they're all different. Now, to make sure that the mean is the same, that means when we add them up and divide by 5, we must get the same number every time. Since what I created for the first set adds up to 75, we also need to make sure that B adds up to 75 and C adds up to 75. That way, we have 75 divided by 5 as the mean for each one. So I kept 5, 20, and 25 the same in each, and then I just did a little addition and subtraction to come up with 12 as the missing number for B and 11 as the missing number for C. So I've made sure that all sets add to 75 so that the means are the same, but the middle values have to be different so that there are different medians. Number 11 is similar, but opposite. This time, we want to make up 3 data sets with 5 numbers each that have the same median, but different means. Again, your answers will all vary, but here's one possibility and how I came up with it. This time, to make sure that they have the same median, I made sure that 15 was the middle number for all of them. Then I just have to make sure that they add up to different sums, because different sums divided by 5 will give me different means. So I used 5, 10, 15, 20, and 25 for the first one again. Keeping 15 as the middle number, I made 13, 14, 15, 16, 17 my set B, which adds up to a different number than 5, 10, 15, 20, 25 does. And for C, I kept 15 as the middle number, but this set is 4, 8, 15, 16, 23. Again, adding up to something different that A adds up to and something different that B adds up to. So all sets have the middle value in order of 15, so the medians are the same, but the sets have different sums, so the means are going to be different. Number 12. A statistics professor surveyed his class, asking how many other classes each student was taking that semester. The results are listed in the frequency table below. Number 12 says find the mean number of other classes that this professor's students are taking. The frequency table we're given had the response of 1 happening 3 times, the response of 2 happening 5 times, the response of 3 happening 7 times, the response of 4 happening 9 times, and the response of 5 happening 11 times. I'm taking this frequency table, and I'm adding in another column for the subtotal. That's the multiplication of each. So 1 times 3 is 3. 2 times 5 is 10. 3 times 7 is 21. 4 times 9 is 36. 5 times 11 is 55. If I add up the frequencies that were given, that will tell me how many responses there were. That will give me my N. So 3 plus 5 plus 7 plus 9 plus 11 is 35. 35 is my N. If I add up my subtotals, that will give me the sum of my X's. Because remember, what this would look like all pieced out is 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, 4, 4, 4, 4, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 5, 3 ones, 5 twos, 7 threes, 9 fours, 11 fives. And if I add those all up, that would be adding up the subtotal column. 3 plus 10 plus 21 plus 36 plus 55 gives me the sum of X's of 125. For the mean, we add them all up, the sum of the X. We divide by how many there are, the N. That's 125 divided by 35, which is 3.6. Number 13. A chemistry professor is analyzing her students' performance on their last quiz. The results are listed in the frequency table below. 13 says to find the mean score on this quiz. So we do the same thing we did in the last question. It's given as a frequency table, which is shorthand for a table that has 12 11s, 15 12s, 18 13s, 17 14s, 11 15s, and 7 16s. So if we add up the frequencies, 12 plus 15 plus 18 plus 17 plus 11 plus 7, that'll give us the number of students that we're looking at. That means that N, when we add those together, is 80. In order to find the sum of the X's, we need to multiply out our X's times the frequencies first in a subtotal column. 11 times 12 is 132. 12 times 15 is 180. 13 times 18 is 234. 14 times 17 is 238. 15 times 11 is 165. 16 times 7 is 112. We add those all up. 132 plus 180 plus 234 plus 238 plus 165 plus 112 is 1061. So the sum of our X's is 1061 divided by N, that's divided by 80. 1061 divided by 80 gives us a mean of 13.3. Number 14 says below are the number of scenes each of 4 of the performers who are scheduled to appear for a show. So 2, 3, 5, and 6 are the number of scenes of each of 4 of the performers who are scheduled to appear. That implies that there are more than 4 performers in the show, but this is just for 4 of them. That means this is a sample, not the entire population of performers. This is just 4 of the performers, a sampling of 4. So when we're asked to find the mean and the standard deviation of this data set, with standard deviation, we have to use the formula that has the n-1 in it, because that's what we use for samples. So a column for x, 2, 3, 5, 6, rows for each of those. Then we need a row for the mean, but we have to find the mean first. So add up our x's, 2 plus 3 plus 5 plus 6 is 16. Divided by n, so divided by 4, we get 4. And we use Xbar because it is a sample. So Xbar is 4. We can fill that in the Xbar column. 4, 4, 4, 4. That enables us to go on and find standard deviation. The next step is a column for x minus x bar. 2 minus 4 is -2. 3 minus 4 is -1. 5 minus 4 is 1. 6 minus 4 is 2. Then we have a column for the squares. We have to square the differences. -2 squared is 4. -1 squared is 1. 1 squared is 1. 2 squared is 4. We need to take the sum of the squares. 4 plus 1 plus 1 plus 4 is 10. So the sum of the squares is 10. N minus 1 would be 3. 4 minus 1 is 3. So we need the square root of 10 over 3. 10 divided by 3 is 3.333333, and we need 3s. We need a lot of 3s to make sure that we come out to 1.83 when we take the square root. If you only have a few 3s, you're not going to get 1.83. But if you have a lot of 3s, you'll hit that number. Number 15. Below are the weights in pounds of 6 of the entries in a local squash growing contest. And again, since it says that this is just 6 of the entries and not all of the entries, this is a sample. So we're using the same formula that we did in the last one. The weights we're given are 18, 23, 27, 32, 35, and 39. So we make an X column with rows for each of those entries. We need to find the mean for the mean column, add them up, and divide by how many we have. So 18 plus 23 plus 27 plus 32 plus 35 plus 39 is 174. We have 1, 2, 3, 4, 5, 6. So we're dividing by 6. And 174 divided by 6 is 29. Again, since this is a sample, we're using Xbar. We can fill in a column for Xbar, 29, 29, 29, 29, 29, 29, which lets us see our subtraction more nicely than if we didn't have this column here. This column is optional, but I think it's very helpful to have for the calculation, because you don't have to think each time what was X bar and then do the subtraction. You can see it. 18 minus 29 is -11. 23 minus 29 is -6. 27 minus 29 is -2. 32 minus 29 is 3. 35 minus 29 is 6. 39 minus 29 is 10. Then we square each of those for the square column. -11 squared is 121. Negative 6 squared is 36. Negative 2 squared is 4. 3 squared is 9. 6 squared is 36. 10 squared is 100. We need the sum of these squares. 121 plus 36 plus 4 plus 9 plus 36 plus 100 is 306. So the sum of squares is 306. N minus 1 would be 6 minus 1, that's 5. So we want the square root of 306 over 5. 306 over 5 is 61.2. The square root of 61.2 is 7.82. So the standard deviation was 7.82. Now, this question said find the mean and the standard deviation. But if it had just asked for the standard deviation, we would have to do all of that anyway, because we can't find the standard deviation without finding the mean first. Oops. Number 16. Below are the weights in pounds of 6 entries in a local pumpkin growing contest. And again, since it specifies that there's 6 entries and not all of the entries, we are dealing with a sample. So same formula again. Find the mean and the standard deviation of this data set. So to find the mean, we add them up and divide by how many there are. 123 plus 139 plus 144 plus 150 plus 158 plus 165 gives us 879. 879 divided by 6, because there's 6, gives us 146.5 as our mean, as our X bar, because it's a sample. So one column for all of our X's, an optional column that lists out the mean each time, and we can do our subtraction. 123 minus 146.5 is negative 23.5. 139 minus 146.5 is negative 7.5. 144 minus 146.5 is negative 2.5. 150 minus 146.5 is 3.5. 158 minus 146.5 is 11.5. And 165 minus 146.5 is 18.5. So we have our differences. We need the squares next. So square the difference column. Negative 23.5 squared is 552.25. Negative 7.5 squared is 56.25. Negative 2.5 squared is 6.25. 3.5 squared is 12.25. 11.5 squared is 132.25. And 18.5 squared is 342.25. We need the sum of the squares. So add up 552.25 plus 56.25 plus 6.25 plus 12.25 plus 132.25 plus 342.25. And we get 1,101.5. N minus 1 would be 6 minus 1, that's 5. So we want the square root of 1,101.5 divided by 5. 1,101.5 divided by 5 is 220.3. The square root of 220.3 is 14.84. So standard deviation is 14.84. Number 17. Make up 3 data sets with 5 numbers each that have the same mean but different standard deviations. So this one's a little bit trickier than coming up with mean and median because it involves standard deviations. Since they have to have the same mean and they all have 5 numbers each, all 3 of your sets have to add up to the same number. So I, again, am using 5, 10, 15, 20, 25 as my first set. That means that since that one adds up to 75, all of them need to add up to 75 so that the means are the same. For set B and C, I kept 5, 20, and 25, but my number 2 and number 3, I made them different, but still adding up to 25. So my number 2 and number 3 were 10 and 15 for A. I made them 12 and 13 for B and 11 and 14 for C. So the second and third add up to 25. Everything else is the same. That means each of these sets adds up to 75. They all have 5 numbers each. So the means are all the same. But the standard deviations for both are different. I'm not going to show the calculations, but the standard deviation of A was 7.91. The standard deviation of B was 7.71. And the standard deviation of C was 7.78. How do I know that the standard deviations are all different if we didn't calculate it? Well, each set has a different sum of squares. So the standard deviations are all different. We just need to make sure that when we take each number and subtract the mean and then add all that up after squaring, we get different values. So it's a little more complicated to come up with than mean and median when we involve standard deviation. But this is the strategy that you would use. Number 18. A sample of 30 distance scores measured in yards has a mean of 7, a variance of 16, and a standard deviation of 4. When we say there's a variance of 16 and a standard deviation of 4, variance is what we call the standard deviation calculation before we take the square root. So if we just did the sum of squares divided by n minus 1, we would have something called the variance. The square root of the variance would be the standard deviation, the last step in that formula. Anyway, you want to convert all your distances from yards to feet, so you multiply each score in the sample by 3. What are the new mean and the new standard deviation? Well, each calculation would also increase by a factor of 3. The new mean then would be 7 times 3, or 21. The new standard deviation would be 4 times 3, or 12. One way to check that, if instead of 30 scores, we had 3 scores with a mean of 7. Well, let's make the 3 scores 7, 7, and 7. That has a mean of 7. And if we multiplied each of those by 3, our 3 scores would be 21, 21, and 21, which would be a mean of 21. The mean also got multiplied by 3. Our original was 7. Our new was 21. And if the means are the same, the rest of the calculation, or I should say, if our mean is multiplied by 3, the rest of the calculation is the same for standard deviation. So you can take my word is my bond, that when we are multiplying each score in the sample by some number, the mean and the standard deviation also gets multiplied by that number. Continuing on from the situation in number 18, you now decide that you only want to look at the distance past a certain point. Thus, after multiplying the original scores by 3, you decide to subtract 4 feet from each of the scores. Now, what are the new mean and standard deviation? Now, for the mean, each score decreases by 4. That means that the mean also decreases by 4. We subtracted 4 from each score. The final mean ends up lower by 4. You can do some calculations to verify that. What's different in this one than the last one, though, is that the standard deviation will not change and is still going to be 12. And this is because the value of x minus x bar doesn't change. Each x and each x bar has decreased by 4. So x minus x bar is still the same. That means when we take the sum of the squares, that hasn't changed. The standard deviation calculation will still be 12. So for example, if there were originally 10 and 5, 10 minus 5 is 5. Decrease them both by 4. 10 minus 4 is 6. 5 minus 4 is 1. 6 minus 1, still 5. So when we're multiplying, both the mean and the standard deviation change by the same factor. But when we add or subtract, the mean changes, the standard deviation does not. Finally, we have number 20. The scores from one class on a homework quiz are listed in the frequency table below. Find the mean and the standard deviation of this data set. These are going to be all the scores from one class. This is an entire population. Since this is a population, instead of X bar, we use mu, and instead of S, we use sigma. And remember that the sigma calculation has an n on the bottom of what's inside the square root, not an n minus 1. So you end up with 2 slightly different answers if you use n minus 1 as opposed to the n that you're supposed to use. This is a population. To get our n, how many there are, we add up our frequencies. Because there's 11 12s, there's 18 13s, there's 16 14s, and there's 10 15s. Adding up the frequencies gives us our n. 11 plus 18 plus 16 plus 10 is 55. The sum of our x's is going to be 12 times 11 plus 13 times 18 plus 14 times 16 plus 15 times 10. So 12 times 11 is 132. 13 times 18 is 234. 14 times 16 is 224. 15 times 10 is 150. Add those together. 132 plus 234 plus 224 plus 150 gives us 740. 740 divided by the 55 that we have. That's adding them up and dividing by how many? 740 divided by 55 gives us 13.5. So mu, the mean, is 13.5. Going on to find standard deviation. We need a row for every score. And we're not going to list out 11 12s and 18 13s and 16 14s and 10 15s. We'll take care of that with a frequency column towards the end. But we want to take our score minus our mean, x minus mu. 12 minus 13.5 is negative 1.5. 13 minus 13.5 is negative 0.5. 14 minus 13.5 is 0.5. 15 minus 13.5 is 1.5. Square each of these. Negative 1.5 squared is 2.25. Negative 0.5 squared is 0.25. 0.5 squared is 0.25. 1.5 squared is 2.25. Now account for the frequencies, because we would have 11 rows of 2.25, 18 rows of 0.25, 16 rows of 0.25 again, and 10 rows of 2.25 again. So multiply them and put it in a subtotal column. 2.25 times 11 is 24.75. 0.25 times 18 is 4.5. 0.25 times 16 is 4. 2.25 times 10 is 22.5. Now, add together the subtotal column. That will give us our total sum of squares. 24.75 plus 4.5 plus 4 plus 22.5 is 55.75. Remember, this formula is divided by n, not n minus 1. So 55.75 divided by 55 is 1.0136. Taking the square root of 1.0136, we get 1.01. Had you used n minus 1, you would end up with 1.02. But the answer we want is 1.01, not 1.02. And that is it for Unit 4.